Hello guys, and welcome to this video. We are going to be learning about gamma of positive half integers. And what do I mean by that? So gamma of 1 over 2, gamma of 3 over 2, gamma of 5 over 2, gamma of 7 over 2. So generally gamma of n over 2. So for all values of n belonging to odd number series 1, 3, 5, 7, and so on and so forth. So we're going to try to evaluate an expression, a general expression for gamma of n over 2. Now in the last video we established that gamma of 1 over 2 is equal to square root of pi. So if you have not watched the last video, or if you're interested in knowing how we derived this from first principle, please see the last video, and I explained everything in full, in detail. So gamma of 1 over 2 is the base case for half integers. Any kind of half integers we're going to be dealing with, whether positive or negative, we are going to make reference to the answer for gamma of 1 over 2, which is root pi. So since it has been determined, we also need another recursive relation from one of the classes we held in the past. So gamma of n plus 1 is still n gamma of n. So these two will be very, very critical in helping me to determine what I want to determine as the general expression for gamma of positive half integers. So let's start with the gamma of 3 over 2. So to get the gamma of 3 over 2, you can break 3 over 2 down in this form as 1 over 2 plus 1. Is that okay? And according to this formula, gamma of anything plus 1 is n gamma of that same thing. So 1 over 2 plus 1 becomes what? N. Okay? Sorry, n is 1 over 2. And you now have gamma of 1 over 2. And if you evaluate this, you're going to get 1 over 2 dot root pi. So this is the gamma of what? 3 over 2. So let's go to the next one, gamma of 5 over 2. So gamma of 5 over 2, you can break it down in this form, something plus 1, and definitely that's a 3 over 2 plus 1. So gamma of 5 over 2 is 3 over 2 plus 1, which means 3 over 2 gamma of what? 3 over 2. And since we have already evaluated the value of gamma of 3 over 2, so this is 3 over 2 dot, the answer for gamma of 3 over 2 is 1 over 2 root pi. So let's keep building. So gamma of 7 over 2 is gamma of, what do you have? 5 over 2 plus 1. Very correct. And according to the recursive relation, at gamma of n plus 1 is n gamma of n. So you have gamma of 5 over 2 plus 1 will be 5 over 2 gamma of 5 over 2. And we have already gotten an expression for gamma of 5 over 2. So we have 5 over 2 multiplied by the expression for gamma of 5 over 2, which is this whole over here. You have 3 over 2, 1 over 2, then root pi. So let's solve for gamma of 9 over 2. So I'm going to ask you to pause the video now and try to get what gamma of 9 over 2 will be. So you can pause now and solve. All right, welcome back. At this point, I expected that you did something like this. 9 over 2 is 7 over 2 plus 1. So you have 7 over 2 gamma of 7 over 2. So if you simplify, you have 7 over 2, and the expression for gamma of 7 over 2 is, we have 5 over 2, 3 over 2, 1 over 2, and root pi. So we see a pattern being developed over here, that when you're evaluating the gamma of an odd number, then all I have, for instance, I want to guess what 11 over 2 will be, So it will be the product of all odd numbers before 11. So the likes of 9 times 7 times 5 times 3 times 1, or each of them divided by 2, then root pi. So this is the pattern, and what I want to do is to convert this pattern into a formula that you will find very useful and interesting. So I call this blessed formula for gamma of half integers. Now we have it looking in this way. Or did I just coin that name now? I think I did. So observing this pattern, I have the product of odd numbers, right? So any odd number that I'm giving, right? Any odd number that I'm giving, I'll just multiply all odd numbers before it. And there is a formula to determine all the odd numbers before a particular number. Is that okay? So before 11, there are 5 odd numbers: 1, 2, 3, 4, 5, and 11 is close to 10. So 5 is actually 10 divided by 2. So it makes sense to say that if I'm giving a gamma of n over 2, okay, I just need to multiply all odd numbers before n. So n minus 2, n minus 4, n minus 6, dot dot dot, then down to my 3, down to my 1. Then I need to divide by 2 raised to the power of the number of odd numbers. Okay, 2, and the number of odd numbers before any odd number is actually just remove 1 from the odd number, n minus 1 divided by 2. Okay, so for 11, there are 5 odd numbers. So 11 minus 1 divided by 2 is 10 divided by 2, which is 5. And you can see 1, 2, 3, 4, 5. So this will be 2 raised to the power of 5. At the end of the day, you multiply it with what? Root pi. So this is one version of the formula. So this is one version of the formula, and this formula works for n greater than or equal to 1. So I want to give us another cooler version of this formula that I think you will enjoy. So gamma of n over 2 can still be replaced in this form. So what if I replace it like this? Root pi all over 2. Okay, I'm going to leave this place empty for now. So I'm going to introduce the product operator in mathematics. The product operator is also pi. Okay, so from I equal to 0 down to, so we are multiplying every odd number from 1 down to the last odd number before it. Okay, so for 11, I'll check all the odd numbers between 1 and 11. That's 1 to 9. I'm not going to include 11. As you can see for this formula, when we are calculating for 11 here, we'll stop at 9. So 1 to 9. So what it means is that I have all odd numbers. This is a general representation of odd numbers, 2i plus 1. So if I goes to 0, I want I to stop. For 11, for instance, I want to start from 1 and I want to stop at 9. So to stop at 9, I'll ask myself, what will I do to this particular formula to make it stop at 9? Of course, this one will still remain 2 raised to the power of n minus 1 over 2 here. So what value of I will give me 9? And you agree with me that the value of I that gives me 9 is going to be what? Definitely 4, right? So it's going to be 4. So it's just trying to tell me that I just have to do n minus 1 all over 2, then minus, because this n minus 1 all over 2 in the case of 11, it gives me 5. And since I want to stop at 9, 5 minus 1 gives me 4, and I'm using 4 because if you do 2 times 4, you get 8 plus 1 and you get 9. So this point that this product should stop at is this formula, and we can still simplify this. Okay, can still simplify this. That's n minus 1 over 2 minus 1. So if you take the LCM, n minus 1 over 2 minus 1, it gives you n minus 1 minus 2 all over what? 2, which is n minus 3 over 2. So the formula is also represented in this way. You have the square root of pi all over 2 raised to the power of n minus 1 over 2. Then you're multiplying the results by pi from I equal to 1, 0, then to n minus 3 all over 2. So 2I plus 1. So this is valid according to my findings. This formula is going to be valid for n greater than or equal to 5. So for n greater than or equal to 5, you can use this formula. So why am I not considering 3 and 1? Because you can easily find the value of gamma of when the numerator is 1 and when the denominator is 3. So for 3, gamma of 3 over 2 is simply root pi over 2, and for 1, gamma of 1 over 2 is root pi. Okay, so this is how it actually progresses. So to use this formula, the recommendation is that n should be greater than or equal to 5. Whichever n you want to evaluate in the numerator here, it should be greater than or equal to 5. Okay, then you should know gamma of 3 over 2 and you should know gamma of 1 over 2. Like, you should memorize it. So some of us might be actually not conversant with this pi operator, but it actually means the product operator. It's a product operator. So let me use this formula to solve gamma of 11 over 2. So we are going to see that through this formula we are still going to get the same thing that we got here. Okay, we're going to get the same thing that we got here. So let's evaluate it. So we have established from this formula that gamma of n over 2, okay, for n greater than or equal to 5 is root pi, then divided by 2 raised to the power of n minus 1 over 2. And you now have the pi operator, which is the product operator in mathematics, I equal to 0, then to n minus 3 all over 2, and you now have 2I plus 1. So this is going to help me to evaluate gamma of 11 over 2. Of course, 11 is greater than or equal to 5. So I have root pi, then divided by 2 raised to the power of 11 minus 1 over 2. Then I now have to evaluate this product, pi I equal to what? 0. Then 11 minus 3 is 8. 8 divided by 2 is 4. So I equal to 0 to 4. And you now have 2I plus 1. So let's see what this gives me. So I have what? Root pi all over 11 minus 1 is 10 divided by 2 is 5. So 2 raised to the power of 5. So I have pi from I equal to 0 to I equal to 4. So this simply means that I'm going to what? Solve the value. I'll be substituting 0, 1, 2, 3, 4 for I, okay, in this formula. And as I'm substituting, I'll be keeping the results. I'll multiply the results for 0 with the results for 1, the result for 2 and 3 and 4. So when I is equal to 0, I have 2 times 0, okay, which is what? 0 plus 1, 1. I'll keep it there. Then dot. When I is equal to 1, I'll have 2 times 1 is what? Let me use brackets so that you see it. 2 times 1 is 2 plus 1, 3. Okay, so when I is equal to 2, then we'll have what? 2 times 2, 4 plus 1, 5. So when I is equal to 3, I have 2 times 3, 6 plus 1, 7. And when I is equal to 4, 2 times 4, 8 plus 1, 9. So you can see that this has ultimately generated the 5 odd numbers between, or the product of the 5 odd numbers between 1 and 11 according to our recommendations. So for using the formula, so you have root pi 2 to the 5. Then you now have your 1 times 3 times 5 times 7 times 9. So if you scatter this one anyhow you want to scatter it, so, or you can decide to distribute this. There are 5 2's multiplying themselves here. That's how we ultimately get 2 raised to the power of 5. So I can decide to share all the 2's between each of the 5 odd numbers between 1 and 11, and I'll have 1 over 2, then let me start with 9 over 2, then 7 over 2, then 5 over 2, then 3 over 2, and 1 over 2, then my root pi. Okay, so you can see that it's still the same thing with what we have gotten over here. Is that okay for this expression over here? So this is how I came about the formula, and I was just playing around, so I stumbled across this, and I felt it could be helpful for some persons that are good with theoretical mathematics and who needs or who are good with memorizing formulas. If you cannot memorize the formula, there's no problem. Just know the pattern. Okay, that gamma of n over 2 is going to be what? N minus 1. Gamma of n, just know this pattern. Gamma of n plus 1 is n gamma of n. So this is your recommendation. So use it to build a pattern. For 9 over 2, then we are multiplying all odd numbers before 9. Okay, and we are dividing them by 2. Each odd number will be divided by 2. Then at the end, we'll now put a root pi. So gamma of half integers are usually multiples of root pi. Okay, they are usually multiples of root pi. There will be a multiple that arises when you multiply this whole thing. Then you now attach root pi to the end of it. So this is the formula, and you saw me doing something like this. Gamma of n over 2 is n minus 2, n minus 4. This is like a pattern for odd number. So for n minus 2. For 11 minus 2 is 9. 11 minus 4 is 7. 11 minus 6 is 5. The next one will be 11 minus 8 is 3. Okay, so this pattern will repeat itself until you get to 3 and 1. Is that okay? That's why I did something like this. Then dot 3 and 1. So the odd number will reduce from the odd number immediately before it's down to 1. So that's what it means. And this 2 raised to the power of n minus 1 over 2 means the number of odd numbers, okay, before this particular number 11. So that is n minus 1 over 2. So that's the general formula. So this is my formula that I'm gifting to you guys for evaluating gamma functions. So in summary, so gamma of what? N over 2 is given to us as what? Root pi divided by 2 raised to the power of n minus 1 over 2 multiplied by pi, which is the product operator from I equal to 0 down to n minus 3 over 2. Then we have 2i plus 1. Then this formula holds for, you can use it for values of n greater than or equal to 5. And the condition is that you should know that gamma of 3 over 2 is root pi over 2, and gamma of 1 over 2 is root pi. Okay, gamma of 1 over 2 is root pi. So gamma of 3 over 2 is root pi over 2. So anytime you want to use this formula, it is assumed that you know gamma of 3 over 2 and gamma of 1 over 2, or you know the gamma for n equal to 3 and n equal to 1 respectively. So this is a formula that I'm giving to you guys. I hope you find it useful, and I hope this formula is going to be useful in mathematics and engineering sometime in the future. So thank you guys for watching, and see you in the next video where we'll discuss the gamma of negative half integers. We'll see how to find the gamma of minus 1 over 2, gamma of minus 3 over 2, gamma of minus 5 over 2, etc., etc. So If you like this video, please subscribe to my channel and share to your friends, share to everyone you know that it will be of benefit to them, and hit the notification button to stay updated. And please watch the next video on the playlist. It's the gamma of negative half integers. So thank you very much. Bye.